Okay, all right. So what we're going to look today is after yesterday's lesson on scatter plots, we're going to look a lot closer at the plots themselves. Not so much how to plot them, we did that already, but look very closely at the patterns of the plots and try to make some sense out of their physical appearances. Okay, so that's what we're going to do. So let's go. Okay, all right. So in order for me to try to get the idea of the lesson through today, let's start right where we left off. Okay, so yesterday or the lesson before, we had talked about what a scatter plot does, right? So it examines the relationship between any two ideas or variables. So in this case, we have height versus weight, right? And when we plotted these points, we got a graph, right? Where it's not a straight line, right? Meaning it's scattered, right? Hence the word scatter plot. And also that since this is not a straight line, although this is not a straight line, you can see that the points are moving in a general direction, right? That the slope is positive, and that for when the height increases, that when the height increases, the weight also increases, right? So that's where we left off. So today I want to talk to you a little bit about the next topic, all right, which it's not even a different topic. It's the smoothest transition from one topic to another, as you will see, which is correlation, which means all about making predictions. So in other words, let me rephrase the question, right, earlier. Uh, does does your height predict your weight? Okay, and that's the question, and that's what correlation does. Okay, so let's talk about it. All right, now again, right before you start any sort of scientific inquiry, you want to ask the question, right? So for example, I'll use the example again, right? Does height predict weight, or is there a relationship between the height and the weight of a person, right? We identify our two variables, we link them together, and then we start gathering data. So for example, someone might be going around the school, right? Measuring people's height and have them step on a scale and then also record that number down, complete a scatter plot. And this is what we're going to talk about today, which is what exactly is the correlation here? Okay, and I want to present correlation in two different ways. One is via a graph, and two is via a number called the correlation coefficient. And I just want to say this also, that I know a lot of times when you guys are in math class, even if you don't say it out loud because you think, it might be a very rude question to ask your teacher, such as, hey, Mr. Ring, what's the point of learning this? We'll never use it again, right? You're not the only one, you're not the first one, and you won't be the last person to ask me that question or asking yourself that question. Uh, in this case, right, there's quite a bit of relevance because this research goes back 100 plus years. All right, so this is to this date is the most, how do I say it? It's the most ironclad, it's the strongest, it's the most how do I say it? It's the most unbreakable scientific research concept out there. All right, it's backed by 100 years of usage, research, and refinement. And also, if we throw this out, there's a saying, right? Throwing the baby out with the bathwater, right? You guys ever heard that saying, right? Like it's the same thing. Like if we were to throw this out and someone were to come across to you and say, you know what, I don't believe in correlation, it doesn't exist, then what you're saying is, I don't believe in anything that I've read in the social sciences. Okay, so what are social sciences? Meaning it's the study of social issues. So for example, is IQ related to income, right? Things like that. You can even ask a crazy question like, do dog owners make more money than cat owners? By the way, the answer of that is supposed to be yes. Okay. So again, right? Next time, by the time you're done with this unit, right? If someone gets into an argument, even if it's an adult, and they say, I don't believe in correlation. Correlation is just something that's made up, right? You can prove to them, no, it's not, right? And not only that, worse yet, if you throw this concept away, then you can throw away just about any sort of studies we've conducted in the last 100 years. And I don't think that anyone wants to do that. Okay, so what I'm also trying to say then is this is extremely heady, serious, and important concept. Okay, all right, so now let's get the official definition of a correlation down, all right, while people are moving things frantically from one place to another, because today is actually Wednesday, the day before the winter storm was supposed to come. So people are acting very frantically, and they're trying to deliver all their stuff before the storm hits, I think, because today is especially busy outside. All right, anyways, so what's a correlation? Correlation just means correlation, how two things are related together. Okay, so now correlation is positive when the values increase together, meaning something like this. Meaning correlation has a positive slope, right? When they move together, meaning, right, as your height increases, so would your weight. Okay, that's what that means. So that would cause a positive slope, which means a positive correlation. On the other hand, a correlation is negative when one value decreases as the other one increases. So I'll give you an example. Hold on, let me think of an example real quick. Oh, okay, so the time amount spent studying, actually, no. Let's take video games, right? The amount of time you spend playing video games versus your grade, right? I don't know, in math class or something, right? So the more time you spend playing video games, the lower your grade is going to be, right? So like this. So the line will look something like this, right? So let's say you spend 10 hours playing video games, your grade is going to start approaching 0. Okay, so that's a negative slope. All right, now let's talk what they look like in terms of the graph, right? Like the one we did yesterday with height and weight. So here, as you can see, in this case, there's positive correlation, all right, for this graph. Moreover, it's so positive that the graph is perfectly straight, which means they have positive correlation. So an example I can give you is something like, I don't know, rain versus precipitation level. Now, those two things are practically one and the same, right? Precipitation, I hope I spelled that correctly. Meaning, right, the more rain there is, the higher the precipitation. But those things are almost one and the same. So it's going to have a positive, perfect positive correlation, which means it forms a straight line. Now, in the next one, where you have high positive correlation, right, here, we don't have a perfectly straight line. But again, this is kind of like the height versus weight argument, right? You can see that these, although they are somewhat scattered, they're not completely scattered. They're a little bit scattered, but they're in the positive direction. So we say they have positive, high positive correlation. So an example I will give you is the height versus the weight. Okay. Now the third one is low positive correlation, which means like the points, you see how the points are fairly scattered, right? More scattered than the one to the left, at least. But they're still kind of moving up, right? So this one would be something like, let me think. I'll use the cat owner, dog owner thing, all right? So if you have a dog, right? You might make, you know, you might make more money, right, than someone who has a cat, maybe, all right? But not a very strong relationship. Okay, so meaning being a dog owner does a somewhat okay job of predicting whether how much money you make or not, but it's not great. Okay, all right. Now, this next one, have you noticed the points are all over the place, right? So it's completely scattered. So in that case, there's no correlation, meaning like what one thing has to do with another has nothing to do with one another, actually. So let me give you an example. The flavor of the ice cream you pick versus your grade, right? Like it doesn't matter. Who cares, right? Like if you like, pistachio, it doesn't mean you have a lower grade, or if you like, Rocky Road, that you would have a higher grade, right? No relationship whatsoever, right? Related, right? No relationship. No, look right here. No relationship whatsoever. No relations, right? Now here, as we kind of moving to in on the spectrum, right, from perfect positive all the way to the other end, let's look at this. Low negative correlation, right? The points are kind of scattered, not perfect, certainly, right? But they're trending in a general negative direction, meaning the more one thing happens, the less something the other thing happens. So let me give you an example. Let's see. Should I use clouds versus? Actually, no. That's a perfect negative correlation. I'm gonna save that for that last one. Um, Cloud versus sunshine. Perfect. That's a perfect one. Okay, I gotta think about this one though. Low negative correlation. Let me press pause and think about it real quick. Okay, so I'll go with this. All right. So let's say, right, the hypothesis that, dog owners make more money than cat owners, right? So let's say if you have a cat, you're going to make less money. Now, again, right, sounds very spurious, right? It sounds very suspect that that's even true, but let's entertain that maybe is true, right? So the, right? Or even this, all right? Let's do something even kind of funnier, right? The more cats you own, right, the lower your income, something like that, okay? Something crazy like that, right? Is it true? Maybe, not likely, because the points are so scattered. So it might be true sometimes, and sometimes it might not be true, right? Or that sometimes there is a relationship, or sometimes that you can predict it, right? Okay, now this next one, right? High negative correlation. Let's go back to the studying one, right? Video games. The more video games you play, the lower your grade, right? And it's fairly high negative correlation, right? Like you can predict this pretty well. So the more time you spend playing a video game, that would predict that your grade is going to be pretty low. Okay. Now, perfect negative correlation. Notice how this is a perfectly straight line. So this is the one like cloud versus the sun. The more cloudy it is, the less sun there's outside. Like that's their like definition of one another, right? So that's a perfect negative correlation. Now, let's bring numbers into this then by looking back at this graph, okay? So looking at this graph, looking at these graphs then, let me use a highlighter. All right, so let's see, let's use, doesn't matter what color I use actually. All right, so perfect positive correlation has a correlation of 1. So R equals 1. So if something is perfect correlation, that number is 1. So it's a scale, by the way. Just so you know, it's a scale between 1 to -1. All right, let me draw out a scale for you guys. So the scale looks something like this, right? 0 on one end, +1, which means perfect positive correlation, and then -1 is perfect negative correlation. And that's it. That's the range. That's the range right here. All right, there's no correlation of 2, 3, or -1, -1.5, things like that. Okay, it's a range. Okay, I know this is a lot of information. All right, so now let's look back. All right, so a perfect positive correlation is 1. Now look on the other side. A perfect negative correlation is -1. All right, again, perfect positive 1, perfect -1, and in the middle of that is 0. No correlation at all. And then you got your, like, 0.9, which is really high correlation, 0.5, right down the middle, right? Like, it happened. 0.3 is really low positive correlation. 0 is no correlation. Okay, now let's see how we're doing on time today. I think I gotta stop now because I want to use this time to talk to you guys in class. Okay, so let me stop now. All right, thanks for watching. Let's come back to class. We're gonna go through this some more. Yeah, all right. See you in class.
OMG, that was so good.